afternoon to everyone. I am Dr. Kiran Jaiswal, Associate Professor, Chemistry Department, Buddha PG College, Kushinagar. My topic is the ionization potential, which is the syllabus of the B.Sc Part 1 students. First of all, we see that what is the ionization potential. What is the ionization potential? What is the ionization potential? The amount of energy removed to an electron, the amount of energy to remove an electron from an isolated gaseous atom, from an isolated gaseous atom from the in ground state to form an cation. The amount of energy to remove an electron, to remove an outermost electron from an isolated gaseous atom in ground state to form an cation is called ionization potential. The amount of energy to remove an outermost electron from an isolated gaseous atom in ground state to form an cation is called ionization potential. It is expressed in electron volt or kilocalorie per gram atom. It is expressed in electron volt or kilocalorie per gram atom. It is represented as IP. In short, it is represented as IP. I means ionization, P means potential. In equation form, it can be written as M gas isolated atom plus energy required is equal to M gas plus electron. M means atom in gaseous state, isolated atom in gaseous state, when the energy to remove an electron, energy required to remove an electron is known as the ionization potential, and that is this M gas cation plus this is the cation plus electron. The removal of electron from an isolated gaseous atom, the energy required to remove the electron from an isolated gaseous atom is known as the first ionization potential. ionization potential. That is, when we remove the electron from an isolated gaseous atom, then which energy is required to remove the electron from an isolated gaseous atom, that energy is known as the first ionization potential. And the energy required to remove an electron from an cation, that is this. The energy required to remove an electron from a cation is known as the second ionization potential, and the energy required to remove the cation from second cation is known as the third ionization potential, and so on. It can be written as this. This first, second and third ionization potential can be written as equation form in this way. The first, second and third ionization potential can be written in equation form like this. That is M gas plus I1, M gas plus cation plus electron, M gas plus I2 is known as the M gas plus electron, M gas plus I3, M gas plus electron, M gas N plus IN, M gas plus M gas plus N P electron plus 3. That is 1. This I1, I2 and I3, this I1, I2 and this I1, I2 and I3, I1, I2 and I3 is known as the first, second and third ionization potential. The order of this I1, I2 and I3 will be this. I1 is less than I2 is less than I3 and so on. That is, the order of this I1, I2 and I3, first, second and third ionization potential will be I1 is less than that of I2, is less than that of I3 and so on. From this equation, it gives the conclusion that the ionization, the successive increase in the ionization potential is due to the fact that it is difficult to remove the electron from the cation having the higher positive charge than the cation from the have the lower positive charge. From this successive increase in the ionization potential is that the more energy is required to remove the cation having the higher positive charge than the cation having the lower positive charge. So I1 is less than that of I2, I2 is less than that of I3 and so on. This is the ionization potential. Now we see that how the ionization potential varies in the periodic table. That is, how the ionization potential varies in the periodic table, that is in the group and in the period. Ionization. First we see the ionization variation of ionization potential. First, variation of ionization potential in group. Variation of ionization potential in group. The ionization potential on moving in group from top to bottom decreases. The ionization potential on moving in group from top to bottom, the ionization potential on moving in group from top to bottom decreases. The reason is that when we move in the group from top to bottom, the size will increase in the group. So the attraction between the nucleus and the outermost electron will be decreases, and so the outermost electron can be released easily, and a less amount of energy will be required to remove the outermost electron from the atom. So the ionization on moving from top to bottom in the group, the ionization potential decreases because the size will be increased. The second point is the variation of ionization potential in period. Variation of ionization potential in period. The ionization potential on moving from left to right in period increases. The ionization potential on moving from left to right in period increases. The reason is that when we move from left to right in the period, the atomic size decreases. So due to this decrease in the atomic size, the attraction between the nucleus and the outermost electron will be increased, and the electron will be tightly bound, so a large amount of energy will be needed to remove the outermost electron. So the ionization potential on moving from left to right in the period increases. This is the variation of the ionization potential in the group. Now we see that which is the factor which influence the ionization potential. Now we see that what is the factors which influence the ionization potential. What is the factor which influence the ionization potential? First factor is the atomic size. Which factors? What factors? Factors which influence the ionization potential. First factor is the atomic size. Factor which influence the ionization atomic size. As we know that greater the size is inversely proportional to 1 upon ionization potential. Atomic size, greater the size, smaller will be the ionization potential. As the size increases, the ionization potential decreases, because the size increases, so the force of attraction between the nucleus and the outermost electron will be decreases, and so the ionization, a small amount of energy will be needed to remove the outermost electron, so the ionization potential decreases. As the size increases, the ionization potential decreases. This is the inversely proportional. Size is inversely proportional to 1 upon ionization potential. Second is the nuclear charge. Second is the nuclear charge. Greater the charge, greater will be the ionization potential. Any greater charge will be directly proportional to ionization potential. Nuclear charge. Greater the charge, greater will be the ionization potential. The reason is that as the charge on the as the charge increases, then the ionization potential increases, because the charge increases, so the electrostatic attraction between the nucleus and the outermost electron will be increases, and a large amount of energy will be needed to remove the electron from outside of the atom. So the charge, as the charge increases, the ionization potential will also increases. The third point is the number of the electron. The third point, number of electron in inner cell. Number of electron in inner cell. As the number of electron in the inner cell increases, the ionization potential will be decreased. As the number of electron in inner cell increases, the ionization potential will be decreased. As the number of electron in the inner cell increases, the number of electron in the inner cell increases, it acts as the shield, or it screens the nucleus, and this is known as the shielding effect or the screening effect. So the effect of the attraction of the nucleus due to this inner electron will less attractive to the outermost valence electron. So the attraction of the nucleus decreases from the outermost to the outermost electron due to the presence of this electron in the inner cell, which act as the shielding electron. So the ionization, as the number of electrons in the inner cell will increase, the ionization potential will decrease, because the ionization because the attraction of the nucleus will not reach more properly than the to the outermost electron, so the ionization potential will be decreased, which is also known as the shielding effect. The shielding effect, the inner cell of the electron, the combined effect of this electron is that the attractive forces experience the less attraction from the nucleus, that is known as the shield effect. Next, number of electrons. The next point is the penetration effect. Penetration effect. The size of the orbital also affect the ionization potential. Size of orbital also affect the ionization potential. The s orbital is more nearer to the nucleus than p orbital, which is more nearer to the nucleus than d then d orbital, and this is more nearer to, it is more nearer than f orbital. Penetration effect, the size of the effect also affect the ionization potential. The s orbital is more nearer to the nucleus than the p orbital, and the p orbital is more nearer than the d orbital, and d orbital is more nearer than the f orbital. It means that the s orbital, a large amount of energy is required to remove the s orbital, then the p orbital, then the d orbital, then the f orbital, and the order of the energy will be s, then p, then d, and then f. The order of the ionization potential energy for s, p, d, and f orbital will be, s ionization potential for s orbital will be greater than that of the p orbital, it is greater than that of the d orbital, and it is greater than that of the f orbital, because the s electron is more nearer to the nucleus, so it is tightly bound, and a large amount of energy is required to remove the s electron, so the ionization potential of s electron will be greater than the p electron, and then the d electron, and then the f electron. So this is the penetration effect. Now the question is, one question is that how the ionization potential, how the ionization potential of beryllium and nitrogen is higher than that of the boron and oxygen. So first of all we see that electronic configuration of beryllium and boron, because the ionization potential of beryllium is higher than that of the boron, and the ionization potential of nitrogen is higher than that of the oxygen. The electronic configuration of beryllium will be the 1s2 and 2s2. The electronic configuration of boron will be 1s2, 2s2, 2p1. In case of beryllium, the electronic configuration of beryllium is through that of the noble gas. That is, in the outermost electron there is the 2 electron, and we know that the s electron has the maximum 2 electron, not more than 2 electron, so it is the fully filled orbital. But in case of the boron, there is only one orbital, only one electron, that it is the incomplete orbital. But it is so in case of the beryllium, the removal of a large amount of energy will be required to remove the s electron, because it is the fully filled orbital and it is difficult to remove the electron, and so large amount of energy will be required to remove the electron in case of beryllium in comparison to the boron, because in boron there is the one electron which is the incomplete orbital, p orbital. So the small amount of energy will require to remove the this p electron. Therefore, the energy of the beryllium is ionization potential of beryllium will be higher than that of the boron. Similarly, in case of nitrogen and oxygen, the electronic configuration of nitrogen will be 1s2, 2s2, 2px1, 2py1, 2pz1. And in case of oxygen, 1s2, 2s2, 2px2, 2py1, 2pz1, 2 to 4 to 6 to 8. The atomic number of oxygen is 8 and atomic number of nitrogen is 7. In case of nitrogen, there is the 3 electron in the p orbital, which is the half filled orbital. In case of, as we know that in the p orbital, the maximum, it has the maximum electron 6 orbital. It has the maximum 6 electron. So in case of nitrogen, there is the 3 electron in the p orbital, which is the half filled orbital, which is the stable orbital. So a large amount of energy will be required to remove the electron from the p orbital in case of nitrogen in comparison to the oxygen, because in case of oxygen there is the only incomplete electron. The oxygen has the incomplete electron, p orbital electron. In that is the 4 electron, which is not half filled, not full filled, not empty. So a small amount of energy will be required to remove this electron in comparison to the nitrogen. So the ionization potential of nitrogen is higher than that of the oxygen. In the case of beryllium and boron, the second point is that the penetration effect. That is, in case of the beryllium, there is the s orbital. So it has the s orbital is more nearer to the p and more nearer to the nucleus. So it has the higher energy. The higher energy will be required to remove the s electron in comparison to the p electron. As we know earlier that the penetration effect for s electron is higher than that of the p, than that of the d, than that of the f. In this case, there is no penetration effect, because both are in nitrogen there is the p orbital and in oxygen there is the p orbital. So there is the only one point that in case of nitrogen there is the half filled orbital. So the large amount of energy to remove this electron in case of nitrogen in comparison to the oxygen, which has the incomplete orbital, not fully filled, not half filled, not empty. So the ionization potential of nitrogen is higher than that of the oxygen. The another example is that the ionization potential of magnesium. The another example is that the ionization potential of magnesium and aluminum is higher than that of magnesium and aluminum is magnesium and phosphorus. The ionization potential of magnesium and phosphorus is higher than that of aluminum and sulfur. The ionization potential of magnesium and phosphorus is higher than that of aluminum and sulfur. Similarly, the electronic configuration of magnesium will be the 1s2, 2s2, 2p6, 3s2, 3s2. That is the atomic number of the magnesium is the 12. 1s2, 2s2, 2p6, then 3s2, 12. And the electronic configuration of aluminum 13 will be 1s2, 2s2, 2p6, 3s2, 3p1, 3px1, then 12, 13. In case of magnesium, it has the fulfilled s orbital. So a large amount of energy in case of magnesium will be required to remove this electron in comparison to the aluminum. In case of aluminum, there is the incomplete p orbital. So a small amount of energy will require to remove the p electron. So the ionization potential of magnesium is higher than that of the aluminum. The second point is the penetration effect. In case of magnesium, the s orbital. So the s orbital is, according to the penetration effect, the s orbital will be nearer to the nucleus, and so it is tightly bound. So a large amount of energy will be required to remove the electron. So in comparison to the aluminum, where the p orbital in comparison to the p orbital, so the ionization potential of magnesium is higher than that of the aluminum. Similarly, in case of phosphorus, where 1s2, 2s2, 2p6, 3s2, 3p3, 15. The atomic number will be the 15. 10, 15. And sulfur, atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4. Here only one point, that is in case of phosphorus there is the half filled p orbital. So half filled p orbital, so the energy, large amount of energy will be required to remove the this p electron, because is the stable state. P orbital is the half filled, empty or fully filled orbital. If the orbital is empty, full filled or half filled, then they will be the stable state. So the 3 electron which is the half filled, so a large amount of energy will be required to remove this p electron in comparison to the sulfur, where the incomplete orbital, that is the 4 electron in the p orbital. So the ionization potential of phosphorus is higher than that of the sulfur. That is okay.